what is the beta ratio on hydraulic filtration? Let's say you have a filter element. Let's say this is your filter element. And let's say you have fluid coming in here. The beta ratio is basically the efficiency of the filter. Let's say how we're going to measure the efficiency and how the beta ratio comes into play. So let's say we're going to measure the efficiency of this filter on 3 micron. So let's say we have, for the sake of this exercise, we have, let's say, 100 particles greater than 3 micron. So we have 3 micron, 100, greater than 3 micron, 100 particles coming in. And let's say you have the flow going out of this filter. This is going out, and you have 10 particles. Let's say you have 10 particles greater than 3 micron. So how do you calculate the beta ratio and the efficiency of this filter, right? So the beta ratio is basically what you have is 100 divided by 10 equals 10. That is a beta ratio, beta 10, which it will give you an efficiency of 90%. So a filter of a beta ratio 10 give you an efficiency of 90%. What if it was an efficiency, or I would say a beta ratio of 20? If you have a filter that has a beta ratio of 20, now you have an efficiency of 95%. If you have a beta ratio of 75, you have an efficiency of 98.7%. Once you get to a beta of 75, once you get to this efficiency level, we're talking about absolute filtration. So we're going to say absolute beta 75 or higher. And the other one is nominal filtration. That says nominal right there. Can't read it very well, but that's what it says. So anyway, guys, so absolute filtration, anything that has a beta 75 or higher. Nominal filtration, anything below a beta ratio of 75. Usually, companies can give you a filter and say it's a 3 micron filter element, but it's nominal filtration. What they're saying is it can filter, it might catch a 3 micron particles, but they don't give you a beta ratio. They don't give you a test of efficiency of that filter. So they don't need to tell you the efficiency, because once you say it is nominal, there's no efficiency coming into play. So they can give whatever number they can feel like giving it to you and say it's just nominal. It's just a nominal filtration. It may catch something, but I don't have to guarantee that it has any efficiency. Now, there are also beta 200s, which it can give you a 99.5% efficiency. It can give you a beta 1000, which it can give you a 99.9% 9% efficiency. Now, some people, and this is in the industry, say that once you reach beta 75, anything above beta 75 is considered efficient. And some people care about it, and some people don't care too much about it, or they think it's a mostly marketing language, you know. Um, because at the end of the day, what is important is to maintain a certain level of contamination, a certain level of cleanliness in your oil, according to the to what components you have. So if you can reach a certain level of cleanliness for your oil, then you're good. And usually you can reach those levels at a beta 75. Once you get to that beta 75, usually the filter, I would say it should be good enough to maintain contamination levels that you need in your hydraulic system. An efficient filter that can catch the particles that you need to catch would be able to maintain certain level of cleanliness in your oil. Now, something important when we're talking about betas and efficiencies is also they have to come along with the micron rating. So let's say you have a 3 micron or 5 micron or 10 micron, 20 micron, 25 micron, right? Check this out. You can have a 3 micron filter element, beta 75, and you can have the same exact element, same exact filter, and you can say that same exact filter is 10 micron and it has a beta of 1000. You see how it works? You see, you have this filter element right here. It's a 3 filter element, but next you're gonna say, you know what? I'm not gonna call it a 3 micron. I'm gonna call it a 10 micron. Now it's a 10 micron, and now it's no longer a 75% efficient, a 75 beta ratio. Now it can jump up to beta 1000 and make it a 99.9% efficient, but at a higher micron rating. So it is important when you are going to talk about efficiency, when you're going to talk about the beta ratio, that you talk about the beta ratio and you also include the micron rating that you're talking about. What is the efficiency? What is the beta ratio along with the micron rating that you're talking about? Because then, you know, that's when the game of word starts. That you have a beta 1000, you have a beta 10,000, and so on, right? And it's a much higher number, but it's very important to check what beta micron you may be looking at, and it has to be guaranteed. It has to be absolute filtration. So on the nominal filtration, you can also put whatever range that you have for micron rating, but you don't have to give an efficiency for the filter. So that is how you calculate the micron rating. That is how you calculate the beta. I would say, you know, a lot of companies, they can offer you the betas, the ratios that they want. But at the end of the day, guys, I would say what is important is to have good clean oil in your system, and I will go with an absolute filtration, and I will go with a minimum of 75, a better 75 for as efficiency to put on your hydraulic system. And I'm talking about pressure line, return line filters. And if you want to explore, somebody offering you a 200 or a 1000 micron rating or so on, you're welcome to explore it and put it in there. But I would recommend very minimum, at least it's beta 75. That is to work to maintain good contamination levels, clean levels in your oil. So anyway, guys, that's the video for today. We'll see you next time. Bye bye.